Awesome. And I'm so excited to introduce Chelsea Fernandes. She's a software development engineer for Amazon, where she works with the Ring product. Before that, she was a data engineer for Watt EV, working on data-driven technology for electric-powered fleets. Her achievements were also amplified by a successful internship at the Alexa AI Labs. Her leadership in the Intelligent, Secure, and Energy-Efficient Computing Systems Club led her to contribute to multiple national and international conferences, showcasing her research in IEEE proceedings. Chelsea's mission is to empower and guide women in tech, encouraging them to become inventors and creators of tomorrow's solutions. Her interests revolve around demystifying tech concepts, exploring data's transformative power, and championing diversity in the tech landscape, which we're so happy to have you here, Chelsea. The floor is all yours.
Hi, everyone. I hope you are able to see me and hear me here today. Okay, let me start with presenting my screen. Great. Can you see? Yeah, see my screen? Okay, great. Okay, so hello, everyone. Good morning, good evening. My name is Chelsea Fernandes. I will be leading today's presentation. A little bit about me is that, as Lindsay mentioned, I'm a software development engineer at Amazon Ring. I just started there. Before that, I was a data engineer with an electric vehicle startup called Watt EV. I have my master's degree in computer science from Cal State Long Beach. I'm based in Los Angeles, California. I consider myself as a data enthusiast. I'm interested in all things data. I actually started when I was pursuing my bachelor's degree in computer engineering. Data is something that is core of everything we do and everything we build, and it's something that I'm highly interested in. And yeah, I'm excited to present my topic over here today. This is my first time with Women Who Code, and I hope all of you are able to learn something from today's presentation. So let's get started. So this is a bit of agenda overview of what we are going to be covering here today. We'll be starting with the introduction and essence of what is data engineering, what are databases, and how do you go about creating data sets, how do you set up data systems, what are the open source tools available that you can use, what is data management and data pipelining, data visualization, data roles and innovation, how data engineering is shaping technological landscape, and then finally we'll conclude our presentation and do some Q&A. So let's get started. Who are actually our data engineers? So imagine ChatGPT and generational AI, the powerful language models that is taking the world by storm. What do you guys think fuels their ability? If you guessed it's data, then you're right. Just like any great story needs a strong foundation, AI and machine learning rely on solid data infrastructure. But data, however, isn't always organized or readily available. What if there's nothing or like a big mess? How do you get any insight out of that? That's where data engineers come into place. They are the ones who make sure the data foundation is strong, reliable, and ready to support incredible advancements in AI and machine learning. So the next time that you kind of interact with a chatbot or witness the magic of personalized recommendation, remember the invisible hands of data engineers. So beginning with the introduction and essence of data engineering. Imagine data, the raw data, as a bunch of instruments playing out of tune. It would be a total chaos, right? Enters data engineer, the ones who sorts this musical mess. They build systems like data pipelines and databases to turn the chaotic noise into a smooth flow of information. But how do they do it? Well, it's like cleaning up a song. They use techniques like data cleaning and transformation to tidy up the messy notes. They get more in depth by using statistical analysis, machine learning, and domain expertise to find hidden patterns and trends. But they do need tools, just like musical instruments to a symphony. So data engineers use a variety of tools like databases, which are like organized libraries, pipelines, which are like pathways to guide data through different stages, and programming languages that are like scripts directing the flow and shaping the data. Yet data engineering isn't just all about technical skills. Collaboration is key. Data engineers work closely with analysts and data scientists to ensure the information is not just correct, but also practical. It's like a technical teamwork where everyone plays their part, creating a symphony of smart decisions. All right, now let's dive deep into technical details of data sets and databases. Databases are the digital libraries of our data world, systematically organizing information for quick retrieval and manipulation. Picture them as vast shelves where data is neatly stacked, making it efficient to find and work with. Transitioning into dataset creation, it's akin to like a meticulous curation of museum exhibits. It's not just about gathering artifacts, it's about selecting them, arranging them, and presenting them to form a coherent narrative. Similarly, in data engineering, crafting datasets involves defining data structures. It's the blueprint that outlines how the information is organized, what type of data are included, and how they relate to each other. Defining the structure involves setting up tables and fields, creating a framework for the data to reside cohesively. Establishing relationships is another part of databases, which is about connecting artifacts in a museum, ensuring a comprehensive and narrative emerges. Another important aspect of databases is constraints. Introducing constraints is pivotal. It's about setting rules for the exhibit, maintaining data integrity, and usefulness by preventing errors and inconsistencies. Now, let's study more about the databases. There are mainly two types, relational and non-relational. As data engineers, it is a crucial decision which lies in choosing between relational, for example, SQL databases, and non-relational, for example, MongoDB. This decision sets the foundation on how data will be structured, accessed, and influences the entire data engineering landscape. Delving into relational databases, they organize data in format of tables, creating a structured framework. This is more suitable for when we know what our data will look like, what kind of fields, what kind of columns they have. This is when you choose a relational database. These databases, commonly associated with a very famous language, structured query language or SQL, bring a rigid yet effective approach to handling structured data. But what do you do when we don't know what kind of data we'll have, our system will have, what kind of columns it will have, what kind of structure it will have? That's when non-relational databases come in place. For example, the very famous MongoDB is a very big open source tool for accessing non-relational database. They offer flexibility to have diverse data types. They break away from a table-based structure, accommodating unstructured or semi-structured data with ease. Understanding the nuances of this model isn't just like a theoretical exercise. It's a practical necessity for data engineers. If you have this knowledge, data engineers can tailor solutions to specific needs. It's the foundation that every organization needs, or is the decision which is very fundamental before starting your data journey. Whether it's the structure order of relational databases or the flexibility of non-relational database, it's the choice that is made strategically based on project's requirement. Now let's dive into the intricacies of setting up data systems. As data engineers, the first step in setting up data system is to lay foundation with a robust infrastructure. This infrastructure acts as a backbone, ensuring a smooth and uninterrupted flow of data. Think of it as constructing a sturdy highway for data to travel seamlessly. Moving forward, data engineers take the crucial task of deciding on storage solutions, such as data warehouses or data lakes. Now, you may ask, how do you make those infrastructure and storage decisions? Well, there are lots of factors to consider, but some of the factors that I consider the most are scalability, reliability, and performance. When considering storage solutions, scalability takes the forefront. We all know that the data is already so huge, and it's increasing day by day as more number of people come on internet every day, more systems are built. The chosen system must be capable of handling the growing volumes of data without compromising efficiency. Reliability is another key consideration. This data system must be trustworthy and available when needed. It's like ensuring the highway we built is always open to data traffic. Performance is another driving force. The chosen storage solution needs to operate at optimal speed, ensuring that the data can be accessed and processed swiftly. So keeping this key consideration in mind, we can choose infrastructure that adheres to all of these considerations. Now, continuing to our journey to setting up data systems, let's focus on another aspect, that is data quality assurance. In the intricate world of data systems, ensuring data quality is paramount. It's not just about having data, it's about having accurate, complete, and consistent data. Now, how do we ensure that we have the highest quality or highest standard of data? This is again where data engineers play a big role. They implement a series of measures known as validation checks, error handling, and profiling techniques. Validation checks are like gatekeepers, ensuring that only valid and accurate data enters the system. Error handling is in place to swiftly address and rectify any issues that may arise, preventing disruption in the flow of information. Profiling technique provide a deep dive into characteristics of data, helping identify patterns and anomalies. It's like conducting thorough inspections to understand the nuances of every data point. But it's not just a technical task. It's the collaboration with stakeholders. Data engineers work closely with those who rely on the data to understand their needs. Collaborative efforts extend to defining quality requirements. What does you might need to ask these questions to your stakeholders or your organization before starting this. What does accuracy mean for the specific data set? How complete should the information be? These are the questions answered in partnership with the stakeholders. Establishing governance practices ensures a standardized approach to maintaining data quality over time. It's like setting up protocols to ensure the ongoing health of our data ecosystem. Now, continuing our exploration of setting up data system, let's dive into another critical aspect, scalability. In terms of data systems, scalability and performance take the center stage, especially dealing with large data volumes. You can imagine scalability as the ability of our system to gracefully expand, accommodating the increasing flow of information without compromising performance. Now, how do we achieve scalability? Well, it starts with a thoughtful system design that anticipates and handles the growing data loads and user demand. It's like building a highway system that not only handles today's traffic, but it is designed to effortlessly incorporate more lanes and routes as the city expands. Implementing best practices becomes crucial. Partitioning data is like organizing lanes for different types of vehicles, efficient and streamlined. Indexing is another tool that acts as signpost, ensuring quick access to relevant data. Caching is another tool that becomes our express lane, storing frequently accessed information for rapid retrieval. When we talk about scalability, we need to consider two important types, vertical and horizontal scaling. Vertical scaling is like upgrading a single road to handle more traffic, that by increasing the capacity of the individual component. On the other hand, horizontal scaling involves adding more roads or lanes, distributing the load across multiple components for improved overall performance. Now, another crucial aspect of setting up data system is data security. Within intricate framework of data system, data security and compliance are not just checkboxes. They are foundational pillars for safeguarding sensitive information. Now, how do we fortify this fortress? It involves implementing a strategic arsenal of measures designed to secure data at every level. Concepts like encryption, which is turning your data into like a secret code to keep it safe during transfer or storage. Access control are like gatekeepers that only allows authorized individuals to access specified data. Auditing mechanisms keep a detailed record of every data interaction for monitoring and security purposes. In the dynamic landscape, the battle against potential threats is ongoing. It's not just about implementing robust security measures, but staying information on regulations is key. Data engineers keep regular updates on legal requirements, such as GDPR, HIPAA, which serves as a compass guiding data system to align seamlessly with evolving compliance standards. It's like navigating through a shifting terrain, ensuring that the fortress not only meets but anticipates and exceeds regulatory expectations. Now, let's explore the steps for building a robust system in this general system diagram. The journey begins with organizing identified relevant data sources, a critical mapping of internal databases, external APIs, logs, or streaming platforms. We need to know where we are going to get the data from. How are we going to set the data sources? How many sources do we have? What kind of data do they have? Do they have JSON, CSV? What kind of fields they have? How do we map these fields? What kind of data types we need? After this step, the initial step is like creating a treasure map, comprehensively understanding where the valuable data resides within the organizational landscape. Once the data sources are identified, the integration process kicks in. Diverse data sets are harmoniously brought together in a unified environment. The choice of data storage comes into play. Cloud-based options like Amazon S3 or Google Cloud Storage or on-premises solutions are evaluated based on multiple factors such as scalability, accessibility, and even cost-effectiveness. This step is like selecting the ideal storage warehouse, a place where our data will securely be housed and easily retrievable. Raw data often requires processing and transformation for usability. This is where tools like Apache Spark come into play for large-scale data processing. To automate the flow of data seamlessly from source to destination, organizations establish data pipelines. This ensures an efficient process, whether in real time or batch processing, resembling the well-coordinated assembly line in a production facility. Processed data is then fed into business intelligence tools like Tableau, Power BI, or Looker. These tools act like analytical engine, creating a visually appealing dashboards that provide a clean overview of clean metrics and trends within the data. The ultimate goal of this intricate setup is to derive actionable insights. Decision makers will leverage the outputs from the BI tool to make informed strategic decisions, optimize their processes, drive business growth, and closing the loop in a data-driven decision-making cycle. Now, starting with an important concept, ETL, which is at the core of any data engineer. ETL is the backbone of data processing, a methodology comprising of three essential and basic steps: extract, transform, and load. It acts as an intricate script, ensuring that data performs flawlessly on digital stage. The first step, initiated with extraction, is where the data is sourced from diverse repositories like different databases, APIs, or even files. It's like analogous to gathering raw ingredients before cooking. Following that, each data source is then transformed. Data undergoes transformation phase, which is like refining the raw ingredients into a delectable dish. Transformation involves complex operations. Our data might need cleaning, standardizing, aggregating, applying calculations to shape the data into its final purpose. The final step is loading. The transformed data proceeds to load stage, which is like similar to serving a prepared dish. It is stored in a destination, often a data warehouse or a database. This is where the refined data finds a structured home, ready to be accessed and analyzed. These skillfully employ languages such as SQL, Python, Java, and other to manipulate and draw meaningful insights from this data and to orchestrate the entire ETL pipeline. Now let's explore the realm of open source tools for data engineering. Open source tools are unsung superheroes in data engineering landscape, providing the necessary arsenal for crafting robust and efficient data pipeline. When I started with my data engineering journey, I did not have access to the paid tools owned by large companies. This is where I started with, which is by using open source tools to build efficient projects that could be that I could showcase to anyone. So some of the open source tools that I've been using in my journey are Apache Kafka, Spark, MySQL, MongoDB, Airflow, Python, and Grafana. These have their own concepts and implementation details, and there are wide amount of resources on internet that could be used to learn these tools. They stand as essential open source tools, each playing a distinctive role in data engineering toolkits. To give you a gist of what they do, these tools act like a specialized musical instrument. They offer capabilities ranging from real-time data streaming, Kafka can be used for that, to large-scale data processing, that's where Spark comes into play, versatile databases, MySQL, which is relational, and MongoDB, non-relational, workflow orchestration, which is where Airflow comes into play, and scripting, Python, and then finally visualization, Grafana. Understanding these tools becomes the key to unlocking the full potential of data engineering. It empowers data engineers to architect efficient and scalable data pipelines. The beauty of open source tools lies in their collaborative nature, fostering continuous improvement and innovation. It's a community-driven effort that focuses on practical aspects of data management and pipelines. Now, talking more about data management and data pipelines, you can see in this diagram, which is like a general architecture of what a data pipeline looks like. You can think of data management as playing a role in as a meticulous librarian. As data engineers, our task is to actively catalog, index, and ensure the quality of data in our digital library. To achieve this, we need clear procedures for organizing the data, implementing robust indexing systems, conducting regular checks to maintain the data quality. It's all about hands-on management, ensuring data is not just stored, but organized, easily accessible, and trustworthy. Data pipeline, which is driven by ETL processes, are the assembly lines where we turn raw data into valuable insights. Picture it as a manufacturing process. To practically implement this, we must design and implement efficient ETL pipeline. This involves defining clear steps for data extraction, transformation, and loading. It's about creating a structured workflow that takes raw data and defines it into actionable information and analysis. Sorry, just a second. Yeah, sorry about that. So for this, we need to make decisions like what are our data sources? Where do we store this data? How frequently do we get it? What kind of cleaning does it require? Do we need to remove duplicates? All this needs to be answered before starting with the ETL process and building our pipeline. Automation is another powerful tool that comes into play while designing this pipeline. We do not want to actively manage these pipelines every single day, ensuring that the data transforms from one stage to another. We need a fully automated pipeline that takes care for each stage of ETL, from extraction, transformation, and loading for every single day. So this is where automation comes into place. A powerful open source tool known as Apache Airflow it can be an efficiency booster. This tool automates pipeline creation, scheduling, and monitoring, reducing errors and ensuring reliability. I would suggest all of you to explore this tool further to have an automated pipeline. We need to learn and implement Apache Airflow to make this happen. This involves setting up automated workflows, scheduling data operations, and monitoring pipeline performance. It's about practical implementation, leveraging automation tools to streamline our data process. At the core of our practical approach is ensuring data integrity. That is basically a data engineer's goal. It's not just the concept, but a practice of making sure data is accurate, reliable, and trustworthy. Practically, this involves implementing data quality checks, validation process, and regularly auditing our data. Yeah. So now moving to the next slide, data visualization. It's another powerful tool that each data engineer needs to have under its wing. So data visualization is not just about aesthetics. It's a vital communication tool in data engineering, enabling effective convenience of insights and trends. Data engineers actively engage with powerful visualization tools like Tableau, Power BI, and Matplotlib. These tools are not just platforms. They are dynamic canvases where data engineers craft their interactive dashboards and reports. You can think of it as a very hands-on process where data engineers leverage this tool to translate raw data into visually compelling representation that tell a clear and actionable story. Beyond the mentioned tools, there are a bunch of open source alternatives. Metabase, Superset, Grafana are another notable names that we can explore in this space. Flexibility to choose the right tool that align with the specific project requirements, ensuring data engineers have the freedom to explore and utilize the best fit visualization tools. Mind you, this process also involves a lot of collaboration. Data engineers collaborate closely with stakeholders, leveraging their domain expertise to design visualization that just goes beyond aesthetics. This collaboration is a dynamic exchange, ensuring that visualizations crafted not only look good, but actively support decision-making processes and contribute to driving tangible business value. Data engineers act as both architects and construction workers in the expansive data realm. They are the masterminds behind designing and maintaining the infrastructure that handles a staggering of 2.5 quintillion bytes of data generated daily. Their role is not just conceptual, but it's hands-on work, building and managing data pipelines. These pipelines are conduits, ensuring an uninterrupted flow of information from diverse sources to destination where it can be processed for meaningful insights. Beyond being data wranglers, data engineers assume the role of quality control guardians in information ecosystem. In fact, 91% of businesses prioritize data accuracy, and data engineers are the key members for this priority. Their meticulous work ensures that the data is not just accurate, but also reliable. Their collaborativeness extends beyond working with machine learning engineers and contributing to the construction of machine learning models utilized by 80% of the businesses. They also engage with data analysts and business intelligence analysts, translating raw data into actionable insights for informed decision making. With the advent of GPT models, we can equate this to striking oil in the data world, unlocking vast reservoirs of information. This search is substantial, with 70% of the businesses planning to invest in AI by 2025. This investment generates new data sources that demand efficient management and utilization. The influx of data poses a challenge and opportunity, making skilled data engineer indispensable in navigating the complexity of ever-expanding landscape. The data boom fuels an increasing demand of skilled data engineers. In US alone, there are around 300,000 active data engineer jobs. and a projected growth of 21% by 2028. This demand underscores the critical role data engineers play in transforming raw data into actionable insights, driving organizational success. The data engineer skill set is undergoing a transformation as well, with automation and new technology taking a center stage. Adaptability is paramount as data engineers. Continuously learning and integrating these tools like AI and cloud computing in our workflows is essential. While the field is evolving, there is still a noticeable gender disparity as well. Women constitute to only 26% of data engineering workforce, highlighting the need for increased diversity and inclusion in this critical field. These are some of the domains where data engineers play a big role: AI and machine learning. Data engineers prepare the training data for AI model that shape accuracy and effectiveness. They build and maintain infrastructure for running and monitoring the AI application. Personalized experiences. Data engineers enable company to personalize user experiences by collecting and analyzing customer data. They build recommendation system, targeted advertising platforms, and many more. Real-time decision making. Data engineers build systems for real-time data processing, analyzing businesses to react quickly to changing conditions. This is crucial in industries like finance, manufacturing, and transportation. Conclusion. So to conclude today's presentation, by emphasizing the critical role of data engineering in fueling the digital insights and driving innovation, data engineers are architects who unlock hidden narratives within data, turning raw information into actionable insight. Their meticulous work empowers organizations to make informed decisions based on thorough understanding of their data landscape. In the era of data-driven decisions, data engineers play a pivotal role. From real-time recommendation to personalized healthcare, they are the builders of future where data is harnessed for transformative impact. Automation tools like Kafka, Spark, techniques like ETL, choosing between relational and NoSQL databases, data pipelines are the backbone of data engineers, streamlining the movement of data. They not only ensures efficiency, but also accelerates the extraction of valuable insights, making data flow seamless and swiftly through the complex systems. Innovation is a collaborative effort. Diverse teams comprising data engineers, analysts, leaders come together to tackle complex challenges. Data engineers stand at forefront, actively contributing to innovation cycle by leveraging their technical expertise and domain knowledge. As I mentioned, data engineering is experiencing unprecedented growth, surpassing the average. This presents an exciting opportunity for individuals to explore careers, invent in talent development, and champion diversity in this critical field. Joining the data revolution means being part of a dynamic and ever-evolving landscape where the demand of data engineers continues to rise and offer a pathway for impacting and fulfilling careers. So invest in the talent and champion diversity in this critical field. So that was it for my today's presentation. Let's start with any question, and thank you so much for your time. This is my LinkedIn QR code as well, if anyone would like to add me. And yeah, I'm ready for your questions. Thank you again.